Calculate the indefinite integral, indefinite because there's no limits of integration on the integral sign. So we're going to get a function, not a number. The indefinite integral of 1 over 3x plus 1 to the second power dx. Step 1, well, they're not giving me the u value here. I have to figure it out myself. So step 1 is to choose the u value. I say we let u equal the number that's being squared in the denominator. It's 3x plus 1. Step 2, calculate the differential du, which we know by definition is equal to u prime dx. So du is the derivative with respect to x of u, which is 3x plus 1, times dx. So du is equal to 3 plus 0, or just 3 dx. Okay, step 3, evaluate the integral as f of u du equals capital antiderivative f of u plus c. So the original problem was the integral of 1 over 3x plus 1 quantity squared in the denominator dx. But we don't want dx at the end, we want du. And in step 2 we saw that du is equal to 3 times dx for this problem here. So we have to introduce a factor of 3 at the end, which means we have to introduce a factor of the reciprocal 1/3 in the front. 1/3 times integral 1 over 3x plus 1 squared times 3 dx. So now we have du at the end. I rewrote it as the 1 over x, the u squared as u to the negative 2, because I'm going to use a power rule to find the antiderivative. I'm going to introduce 1 to the exponent negative 2, and that's going to give me a negative 1, then multiply by the reciprocal of negative 1, and then add c at the end. So I have, when I distribute the negative sign, negative 1/3 times 3x plus 1 to the negative 1 power plus c, which is negative 1 over 3 times parenthesis 3x plus 1 plus the constant c. Now I could distribute multiplication in the denominator, but I chose not to. It's not really that important. So that problem wasn't too difficult. Step 1, step 2, step 3. And you could do it quickly. You don't have to enumerate the steps. You're going to get used to this stuff very quickly.